So far in this course, you have learned what the cloud is, its service and deployment models, regions, the shared responsibility model, and how it is priced. You can now get an application running in the cloud. But here is a truth every cloud professional learns. Getting something running is the easy part. Getting it running well and A2112, securely, reliably, affordably, and in a way you can operate for years and A2112, that is the real skill. The difference between an amateur cloud setup and a professional one is not whether it works on day one, it is whether it holds up under load, under attack, under failure, and under a budget. Today we learn the tool the whole industry uses to design well on purpose, the well-architected framework. It is essentially a checklist of hard-won lessons organized into 6 pillars that you hold any cloud design up against to find its weaknesses before they find you. By the end of this class, you will know all 6 pillars, what question each one asks, and how to use the framework to review and steadily improve any system. This is the class that turns you from someone who can use the cloud into someone who can architect on it. Let us begin. Here is our path for today. First, why a framework matters at all. Second, the 6 pillars as a whole. Third, operational excellence. Fourth, security and reliability. Fifth, performance and cost. And 6, how to actually use the framework. Let us dive in. Let us start with why a framework is needed at all. Because it addresses a very real trap. The trap is this: in the cloud, it is astonishingly easy to get something working. A few clicks, a deployment, and your app is live. That ease is wonderful and 8212, but it hides a danger. 82828 works and 82829 tells you nothing about whether it is secure, whether it will survive a failure, whether it will cost a fortune, or whether anyone can operate it at 3 in the morning when it breaks. Working is the floor, not the goal. The well-architected framework exists to raise your sights from NA8200, 1000 AT200, 200 AT200 to NA800. Is it built well? NA800 AT200, it is a distillation of lessons learned across countless real cloud systems, and A200 AT200, the mistakes, the outages, the runaway bills, the breaches, and A212 turned into a structured set of questions you can ask of any design. Instead of learning those lessons the hard way, one painful incident at a time, you inherit them as a checklist. And that is the key mental shift. Good architecture is a deliberate choice, not an accident. When you review a design against the framework, you are choosing on purpose to check the things that matter before they bite you. It does not make decisions for you and A2112. It makes sure you have considered the right questions. That is what separates architecture from mere assembly. So the takeaway, getting something running in the cloud is easy, but any 8200, it works, and 8200 says nothing about whether it is secure, reliable, or affordable, and 8200. So the well-architected framework distills hard-won lessons into a checklist, turning good design from an accident into a deliberate choice. The framework organizes all of its wisdom into 6 pillars and 8200, 6 distinct lenses you look through when judging any cloud design. Let us name them, because knowing the 6 is half the battle. They are operational excellence and A212, can you run and improve it? Security and A2112, is it protected? Reliability and A2112, does it survive failure? Performance efficiency and A2112, does it use resources well? Cost optimization and A2112, are you spending wisely? And sustainability and A2112, is it resource responsible over the long term? 6 words, 6 concerns. The power of having exactly 6 named lenses is that it makes you thorough. Left to instinct, an engineer will obsess over the 1 or 2 things they care about, and 8212, often performance or features, and 8212, and completely forget the others until an incident forces the issue. The 6 pillars are a discipline against that blind spot. You consciously look through each lens, so nothing important is silently ignored. And crucially, a weakness in any one pillar is a real weakness in the whole system. A blazingly fast, cheap application that is insecure, is not well architected, and 85 too harder. It is a breach waiting to happen. A perfectly secure system that falls over the moment a server dies is not well architected either. The pillars are not a menu to pick from. There are 6 standards a good design meets together, balancing the trade-offs between them. So the takeaway, the framework has 6 pillars: N81, 200, operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. N81, 200 T1, 6 lenses you look through so nothing important is ignored. Because a weakness in any one pillar is a genuine weakness in the whole design. Let us take the pillars one at a time, starting with operational excellence. N8200, the one about running the system well, every single day. The core question it asks is simple. Can you run, monitor, and continuously improve the system smoothly? Not just launch it once, but operate it for years. And A212, deploy changes safely, know at a glance whether it is healthy, and respond quickly when something goes wrong. A system that works but is a nightmare to operate fails this pillar. In practice, operational excellence means a few concrete habits. Automate your operations so routine tasks are reliable and repeatable rather than manual and error-prone. Monitor everything so you can see the system and its health and are alerted to problems before your users notice them. And treat every failure as a lesson. And 80 Swoopao, do a review, find the root cause, and improve the system so it cannot happen the same way again. The reason this pillar comes first in spirit is that operations is where a system lives most of its life. The launch is a day, the running is years. An architecture you cannot observe, cannot update safely, and cannot recover quickly will grind your team down and fail your users, no matter how clever the initial design. Building for smooth operations from the start is what makes a system genuinely maintainable. So the takeaway, operational excellence asks whether you can run, monitor, and continuously improve the system smoothly over its whole life. And 8200 through automation, thorough monitoring, and learning from every failure. And 8112, because a system lives far longer in operation than in its launch. The second pillar is security. And 824, the one that asks whether your data and systems are genuinely protected. This is the pillar you can never afford to skip. The question at its heart is everything protected against unauthorized access and harm? Your data, your systems, your users. And FT9, trust. And 8200 S12, all of it. And in the cloud, where your systems are reachable over the internet and you share responsibility with your provider, this question demands a deliberate, layered answer, not an afterthought bolted on at the end. 3 ideas carry most of the weight. Least privilege. Every user and every component gets only the access it truly needs, and no more, so a compromised piece can do limited damage. Encryption everywhere. Data is encrypted both when stored and when traveling across the network, so intercepting it yields nothing useful. And defense in depth, multiple layers of protection, so that no single mistake or single breach exposes everything. The mindset that ties these together is to assume things will go wrong and design so that they are survivable. Assume a password will leak, a component will be compromised, a request will be malicious. And 8200 and build so that when that happens, the blast radius is small and contained. Security is not a feature you add. It is a property you architect in from the first decision. On every pillar in 39's work. So the takeaway, the security pillar asks whether your data and systems are protected, answered through least privilege, encryption everywhere, and defense in depth. And 8512, built on the mindset of assuming things will go wrong and designing so that a single failure is contained, never catastrophic. The third pillar is reliability. And 8212, and it rests on one unavoidable truth about the cloud: things fail. The question it asks is whether your system keeps working when parts of it fail and recovers when it is disrupted. Servers crash, networks hiccup, whole data centers occasionally go dark. A reliable system is not one where nothing ever breaks, and 812 that is impossible, and 812 it is one that keeps serving users despite things breaking and comes back cleanly after a disruption. Achieving that rests on a few pillars of its own. Redundancy, run more than one of things across more than one location. So the failure of any single component or even a whole zone does not take you down. And 8212. This is exactly why regions and availability zones from an earlier class exist. Health checks automatically detect a failed component and route around it. And tested backups and recovery, not just having backups, but regularly proving you can actually restore from them. The phrase to burn into your memory is designed for failure. Assume any given component will fail and ask N822 what happens then. 822, if the honest answer is N822, the system goes down. N822, you have a reliability gap to fix. The teams that sleep soundly are the ones who assumed failure from the start and build so that it is a shrug, not a catastrophe. So the takeaway, the reliability pillar asks whether the system keeps working through failure and recovers from disruption, and 80-20-12 achieved with redundancy across locations, automatic health checks, and tested recovery, and 80-20-12 all resting on one habit, designed for failure. Because in the cloud things will fail. The fourth pillar is performance efficiency, and 821-12 using computing resources well so the system is fast without being wasteful. The question here is whether you are using the right resources in the right amounts to meet your performance needs. It is a two-sided question, not just N82200. Is it fast enough? A82200, A2200, but N82200. Is it fast enough without throwing far more resources at it than the job requires? A82200, 200, brute forcing performance with a giant expensive machine when a smarter design would do, is a failure of this pillar, not a success. Doing it well means a few things. Choose the right service for the job, and 80-212. The cloud offers many specialized options, and matching the tool to the task beats forcing a general one. Size resources to actual demand rather than guesswork. And use the cloud in 39, S-elasticity, and 82112. Scaling up when demand rises and back down when it falls, and 82112. So you have the performance you need exactly when you need it, and not a moment in 220 S worth of idle excess. Notice how this pillar leans directly on the cloud in 39 S core strengths from earlier classes, on-demand resources, and elastic scaling. Performance efficiency is really the art of applying those strengths intelligently, and 82-watt, being fast by being well-matched and well-scaled, rather than fast by being oversized. It is where good architecture and good economics start to meet. So the takeaway, performance efficiency asks whether you use the right resources in the right amounts to be fast without waste, and 822 by choosing the right service, sizing to real demand, and using elastic scaling, and 822 making the system fast through good matching, not through brute oversizing. The fifth pillar is cost optimization, and 82-pulval, making sure you pay for value, and only for value. Building on last class and 39 as pricing lesson, this pillar turns cost awareness into a design discipline. The question it asks is direct. Are you getting the most value for your spend, with no money leaking away on things you do not need? The Cloud N9 S Pay As You Go model is a gift, but it cuts both ways, and 82-fal, the same ease that lets you spin resources up in seconds, lets you forget them running, quietly billing you for months. Unmanaged, cloud costs drift upward relentlessly. Optimizing means a handful of concrete moves. Right-size everything, and 82i2-POV. Match resources to what you actually use, not the generous guess you made at launch. Choose a pricing model that fits, and 80-80-2 on-demand for spiky or short-lived work, committed or reserved pricing for steady baseline load, as we saw last class. And relentlessly turn off waste, idle machines, unused storage, forgotten test environments. Every one of those is pure loss. The healthy attitude is that cost is a first-class design concern, not something the finance team worries about later. A well-architected system is one whose owners can see what they are spending, understand why, and know that every dollar is buying something they need. Treating costs as an afterthought is how good projects become unaffordable ones. So the takeaway, cost optimization asks whether you pay for value and nothing more, and A2112, do right sizing, choosing the pricing model that fits the workload, and relentlessly eliminating idle waste, and A212, treating cost as a first-class design concern rather than a problem for later. We have the 6 pillars and A2112. Now the crucial part, how do you actually use them? Because the framework in 29's value is in the doing, not the knowing. Step 1 is to review. Take a design and AT212, one you are planning, or a system already running and AT212, and hold it up against all 6 pillars in turn. For each one, ask its core question honestly. Is it secure? Will it survive failure? Are we operating it well? Is it fast, affordable, responsible? Going through all 6 deliberately is what surfaces the weaknesses you would otherwise miss. Step 2 is to find the gaps and name the trade-offs. You will rarely be perfect on every pillar, and that is fine. And A212. The pillars often pull against each other. More reliability can cost more money. More performance can cost more too. The point of a review is not a perfect score. It is to see clearly where you are weak and to make those trade-offs consciously rather than by accident. Step 3 is to improve, starting with the highest risk. You will not fix everything at once, so tackle the gaps that carry the most danger first. And A2I212, usually a security or reliability hole that could cause real harm. Then, review again later, because systems and requirements change. That is the rhythm. Review, find gaps, improve the riskiest, repeat. The framework is a lens you keep applying over a system and T9 time's life, not a certificate you earn once and file away. So the takeaway, use the framework by reviewing a design against all 6 pillars honestly, finding the gaps and naming the trade-offs between pillars, and improving the highest risk weaknesses first and A212, then repeating over the system and 9 size life. Because it is a lens you keep applying, not a one-time box to tick. Let us gather the whole class in one breath. The framework is a checklist of hard-won lessons. So you design cloud systems well, not just working. It has 6 pillars and A2112, operational excellence, security, reliability, performance, cost, and sustainability. Operational excellence is running, monitoring, and improving the system smoothly every day. Security and reliability and A2112, protect data and access, and survive and recover from failure. Performance and cost and A212, use resources well and pay only for what you truly need. And you use it by reviewing against all 6 pillars, finding gaps, and improving the riskiest first. Next class, and A2A2A, high availability, designing systems that stay up no matter what. One idea at a time. That is, the well-architected